What we're going to do today is just background on the trigonometric functions. So far, all the angles that we worked with have been between 0 and 90 degrees, but we're not limited to that. And that's what we're going to work with today. A lot of terminology, but a few things we want to accomplish today. First of all, we're going to apply angles to the Cartesian plane, basically, and see how angles, some of the properties of trigonometric functions when we apply angles to the Cartesian plane. We're going to see what standard position are, terminal side of an angle. We've touched on those topics a little bit. Based on the Cartesian plane and the position of the terminal side, you can determine what the sign, that is positive or negative, of any of the trigonometric ratios is going to be without having to rely on your calculator. That'll be useful for some work we're going to do later in the week. And we're going to determine what's called the reference angle for any angle. And finally, we'll wrap up today by using your calculator to evaluate a trigonometric function for any angle, not just between 0 and 90 degrees, but that's just a matter of hitting a few buttons anyway. Those are the things we want to take care of. They're all going to tie together. First of all, we touched on this idea a few lessons ago last week, but we can take any angle and we can put it on the Cartesian plane. When we do that, there's a little bit of terminology that's worth noting here. First of all, we generally put angles in what's called standard position. And standard position means that one side of the angle lies along the positive x-axis. And from there, we open up the angle. If it's a positive measure, we rotate in the counterclockwise direction. If it's a negative angle measure, we rotate in the clockwise direction. So for example, an angle of 45 degrees would look something like that. Our angle theta would be right in there. The vertex, like we've used it before, would be the point where those two rays meet. The side that's along the positive x-axis is called the initial side. And the side, the other side of the angle is called the terminal side. So while the position of the terminal side is going to change depending on what your angle is, the initial side position doesn't. That's always pointing in the positive x direction. The angles between 0 and 90 degrees are always going to point in which quadrant? They're always going to point up here into the first quadrant. Between 90 and 180 degrees, the angle is always going to point in the second quadrant. Beyond 180 up to about 270 will be down here in the third. And beyond 270 degrees up to 360 will be down here in the fourth quadrant. Okay? Beyond 360, we've essentially hit 0 and started wrapping on a second revolution. We'll talk about those types of angles in a minute. So, very quickly, I just want you to, in your head, picture the angle, and I want you to tell me what quadrant the following, the terminal side of the following angles will lie in. The first one, just take a minute, we'll buzz through them real quick. I just want you to think about what quadrant these will be in. 172 degrees? That's right, that'll be in quadrant 2. It'll be somewhere up here. Actually, 172 is just a little bit less than 180. It'll be getting pretty close to the negative x-axis. Okay, that'll be in quadrant 2. 275 degrees is going to be where? Quadrant 4. There's 270 degrees, so it's going to be a little bit beyond that. That's going to be in quadrant 4. Okay. 583 degrees. Doing exactly what you should do. You reach from your calculator. What are you going to do with your calculator? You see 583 degrees, you're going to... Yeah, it's too big. That's more than a revolution. So subtract 360 to get it down below 360 degrees, then we can picture it. If you take 583 degrees, that's actually the same as what? That's the same as 223 degrees, and that we know is in quadrant 3. It's going to be somewhere down here, so that'll be quadrant 3. Looks good. Negative 120 degrees. Now, we've so far we've always rotated counterclockwise. A negative angle, though, means we're going to drop down 120 degrees. Now, if you drop down 120 degrees, what quadrant are you going to end up in? You're going to be back in quadrant 3. It's going to be back in quadrant 3. Good enough. And one more. 3 pi over 2. Not in degrees, but in radians. Where does 3 pi over 2 lie? Sort of. Sort of the third quadrant. Is it actually in the third quadrant? It's right between quadrants. Where is 3 pi over 2? Remember, 3 pi over 2 is 1.5 pi, right? 1.5 pi. There's pi. Here's 0. There's half a radian, or excuse me, half pi radians. There's pi radians. Here's 1.5 pi. It's right down here. And so we would say it's right on the negative y-axis. It's not in any quadrant, but that's in the negative y-axis, or on the negative y-axis. Okay, well, we've got the locations down. Now, the reference angle. Each one of these angles has associated with an important angle called the reference angle. And the reference angle is the acute angle that gets formed between the terminal side of an angle and the x-axis. It's always acute. It's always less than 90 degrees. Now, the one that's shown up there, we've got a terminal side to an angle that's in quadrant 2. Then our reference angle, R, is going to be always formed between the terminal side and the x-axis. So that would be our reference angle right in there. There's something called a reference triangle that's directly associated with that. If you take your terminal side and always using a vertical line, if you complete and make a triangle by putting in a vertical line, you have what's called a reference triangle. But that reference triangle, or the reference angle, always has to be adjacent to the x-axis, never adjacent to the y-axis. If we had a reference angle in the third quadrant, say it was down here, would the reference angle be here in position 1 or here in position 2? 1 or 2? It would be in position 1. The reference angle would be up here, and the reference triangle would be right there. What if we had an angle whose terminal side was in quadrant 4? Would the reference angle be above or below that? Above. The reference angle would be right here, again, adjacent to the x-axis, and the reference triangle would be right there. Okay. Well, the reference angle is always going to be, as you can see, it's always going to be an angle within a triangle. It's always going to be an acute angle. It's always got to be between 0 and 90 degrees. So, for each one of these 4 angles, let's determine what the reference angle would be. Okay, well, the first one, 155 degrees. You're going to be pointing in the second quadrant. We're going to be somewhere over there. Well, if this is 155 degrees, how many degrees are left for that angle right there? 25 degrees. So your reference angle for that one would be 25 degrees for the 155 degree angle. What about 350 degrees? 350 degrees, you're going to be down in quadrant 4. There's 350 degrees. So your reference angle is 10 degrees. (262 degrees puts us in quadrant 3, just short of 270. If our reference angle is 262, excuse me, if our angle is 262, what's our reference angle going to be? Nope. It's going to be, if the whole thing is 262, this is our reference angle right in there. So what are you going to do to this 262 to find the reference angle? Subtract 180. Right. If you take 180 away from that, this angle here has to be 82 degrees. It's formed right up there. So there's no sure rule to look at a number and subtract 180 or subtract 360 or anything else. We have to kind of visually picture where that angle is, and depending on which quadrants it's in, we have to determine what the reference angle is. Here we had to take 180 minus our angle. Here we took the angle minus 180. Here we took our angle and subtracted it from 360. It's going to be different every time. Last one, 46 degrees. That puts us up here in the first quadrant. If that's a 46 degree angle, your reference angle's got to be 46 degrees. There's our reference triangle, and that reference angle is 46 degrees. So we found our reference angle for each one. We're going to look now at the trigonometric functions and how they apply to the Cartesian plane. Here's what we've got. We want to take some angle, theta. Its terminal side is going to pass through the point negative 4, 7. We want to figure out what the trig ratios are for that angle. Difficult problem to do without a picture. So we're going to make a decent sketch. So that terminal side goes through the point negative 4, 7. That leaves us with an angle theta. Anybody care to give me an estimate of what theta must be? Roughly. Just by judging the picture. Maybe somewhere around 115, 120, 125, somewhere in there. A little bit more than 90. That's good enough for now. Okay, well, let's figure out what the trigonometric ratios are. Well, what we've got is we've got a triangle. Sketch in your reference triangle. Once you draw the side that meets that criteria, going through negative 4, 7, sketch in your reference triangle. We know what the lengths of all these sides are. The opposite side of this triangle, isn't that really just the y-coordinate of your point? It's how high up above the axis you are. So the y-coordinate here is just 7. The x-coordinate tells you the length of the adjacent side, but you have to preserve the sign, the SIGN. So the length of this side is 4, but since it's to the left, the length is negative 4. So we can have negative lengths on these reference triangles. That indicates whether it's to the left or right or up or down. Well, then you can find the length of the hypotenuse with little trouble by the Pythagorean theorem. And that value is called r, typically, for no important reason, but we typically call the hypotenuse value r. Well, if that's r, we know that r squared is equal to 7 squared plus negative 4 squared. Go through the trouble and you're going to find that r is equal to square root of 65, right? You're going to leave it as square root of 65 because we're going to write the exact trigonometric ratios. We couldn't, because we're not done with the problem, so we're going to leave it exact. Later on, we can round it if we need to, but for the purposes of what we're doing right now, we're going to leave it exact. Nice little space there. Okay, well, now we know all three sides of this reference triangle. Now we can answer the question about what are the three trigonometric ratios. This is our angle theta. So we know that sine of theta is opposite over hypotenuse. Well, from right here, what's our opposite side? 7 over, and our hypotenuse in this case is square root of 65. Now we're going to rationalize that, but let's stop right there for just a second. We have not worked with radicals much, but it's important to note that we should. Anytime you've got a radical in the denominator, it's kind of like capitalizing proper names, all right, when you're writing. Even though you don't have to capitalize the first letter of your name to make your point clear, it's just the right way to do it. We multiply, when we've got a radical in the denominator, We get rid of it by multiplying by that radical. So 7 over the square root of 65 really becomes 7 root 65 over. Now, what happens to these square root of 65 times square root of 65? It's just 65. What that does is it eliminates the square root from your denominator. So we rationalize that. A quick step to clean up that answer. Numerically, it's the same. Okay, now, here's the thing. This will maybe add to discussion or drive you crazy. Cosine theta. What is cosine theta for our angle? Well, what's the adjacent side now? Negative 4. Over. Okay, now take out your calculators for a minute. Type in negative 4 divided by the square root of 65 on your calculator. You need to rationalize it in order to do this work. Oh, sure. You can borrow mine. I'll pass that back. Take negative 4 divided by the square root of 65. Isn't it true that theta is going to have to be the inverse cosine of negative 4 over the square root of 65? Right? Okay, well, according to that, what does your calculator tell you then the angle is? If you type that in your calculator, put it in degree mode. Let's work in degrees. What do you get? What? 119.7? We were pretty close by our 120 degree guess. I guess I could have just looked on my notes. Yeah, 119.7. Let's go back. Cosine of theta is negative 4 over the square root of 65. If we rationalize that, we're going to get negative 4 times the square root of 65 over 65. This is getting a little bit messy. What's the last thing that we still need to do that we haven't done? Tangent. What is the tangent of theta going to be? Opposite of 7 over adjacent of negative 4. There's nothing to rationalize. We're done. Take just a minute. What is 7 divided by negative 4? Negative 1.75. Negative 1.75. Everybody agree? Take just a minute. Clear your calculator. Type in 119.7 degrees and hit the tangent button. What is the tangent of 119.7 degrees? Negative 1.75. Okay, it knows that the tangent is going to be negative up here. Well, actually, we're getting pretty far ahead of ourselves. Let's do a couple more, and then we're going to work more with this sine business. Same thing. This time, though, the terminal angle passes through negative 5, negative 3. Okay, make a little sketch. Draw where your terminal side is. We're in quadrant 3. Label the sides of your reference triangle. The opposite side here is going to have to be, that's right, it's the y-coordinate, down 3. The adjacent side, negative 5. Okay, well then you can use the Pythagorean theorem to figure out what the r value is, or the hypotenuse. Negative 5 squared plus negative 3 squared. Square root of 34. Okay, that's hypotenuse r is the square root of 34. Everybody agree with that? Okay, well now we can find the trig ratios. We can slam them out here. This is our reference, or our, that's our angle theta. So tell me, what's the sine of theta? Opposite? Negative 3. Hypotenuse? Square root of 34. So the sine of theta is negative 3 over the square root of 34. Now we'll rationalize that in a minute, but does everybody agree with that? Okay? Rationalize it, multiply both top and bottom by the square root of 34. We don't need to show that step. You can do that in your head. Top becomes negative 3 square root of 34. And the bottom becomes 34. Okay, that rationalizing is a step that you don't need to show. You can just, the bottom squares and the top gets the new radical. Okay, so sine of theta is negative 3 square root of 34 over 34. Cosine theta. Negative 5 over the square root of 34, adjacent over the hypotenuse. Rationalizing becomes negative 5 root 34 over 34. Tangent. Opposite is negative 3. Adjacent is negative 5. Now that simplifies just slightly. What does that become? 3/5. Okay, so we found sine, cosine, tangent. Sine of theta is negative 3 root 34 over 34. Cosine tangent is 3/5. Okay, so we've answered 3 parts of the question. The last part is find out the size of angle theta. Well, let's just use tangent. Okay, let's work with tangent for a minute. Tangent of theta is 3/5. So that means theta is what? Well, before that even, it's going to be the inverse tangent of 3/5. Everybody agree with that? Okay, type that in your calculator. What is the inverse tangent of 3/5? You're not going to like what it tells you. 30.96. Okay, we'll call it, we'll round it off at 1 decimal and call it 31.0 degrees. But you know what? That can't be 31.0 degrees because we're in which quadrant? We're in the third quadrant. So, which one did it tell us? It said the tangent was 3 over 5. Well, what angle would, or where would a terminal angle be that had a tangent value of 3/5? This would be in the first quadrant. Your calculator it doesn't know which quadrant you're in. It doesn't know that the negative side canceled out. So when you ask your calculator what angle has a tangent of 3/5, it assumes you're in the first quadrant. It assumes that you're up here. So what do you need to do to find your angle? Your calculator told you now, it told you the reference angle. Okay, it told you, well, it assumed you were in the first quadrant. It said 31.0 degrees, but we know that that's not our angle because we're in the third quadrant. So we have to go and take a reference angle of 31.0 degrees, which actually makes our angle what? 211. We have to add 180 degrees to that, and we get 211.0 degrees. That's our angle. When you're working with acute angles, your calculator always tells you the correct inverse. When you're working with angles outside of 0 to 90, your calculator only tells you the right angle some of the times, and you need to figure out what the correct angle is. Okay. Well, the opposite side for our reference triangle for this angle is going to be -1. We're down 1, the y-coordinate. Our x-coordinate, or in other words, the adjacent side for our reference triangle will be 3. Now we can find r because, again, we know that r squared is equal to 3 squared plus -1 squared, and that leaves an r value of square root of 10. Okay? So we know our 3 sides, we can find our trig ratios. our angle theta is going to be, it's a rough estimate. Judging by the picture, what's a rough estimate for our angle theta here? 345, 350, somewhere in there. It's going to be closing in on a full revolution, so a little bit less than 360 degrees. So we know that sine theta is going to be opposite over hypotenuse, negative 1 over the square root of 10. Or if we rationalize that, we're going to have negative square root of 10 over 10. Cosine theta is going to be 3 adjacent over hypotenuse square root of 10. Rationalizing, we get 3 root 10 over 10. Tangent. Tangent of our angle is going to be? Negative 1 over 3. That's right. Nothing to simplify. That one's done. Now, I think the first question asked for this, but I overlooked it, probably because I was too excited. But let's find the other three trigonometric ratios, okay? What would cotangent of theta be? Now, these are very easy. You have no work to do. What will the cotangent of theta be? Remember how they pair up. Cotangent is the reciprocal of tangent. So all we do is flip that over. 3 over negative 1. Or in other words, negative 3. Secant of theta? Well, go back to cosine. Don't flip this one, because you rationalize this one to stick the radical in the top. Now, if you flip it over, your radical is going to be back in the bottom. Just go back to this one. Go back to your original. Instead of 3 over the square root of 10, secant of theta is square root of 10 over 3. We don't have to rationalize because the radical is already in the top. Okay, saves a little work. And finally, cosecant of theta is going to be the reciprocal of sine square root of 10 over negative 1, or in other words, negative root 10. Okay, we found all 6 trig functions. Last thing we should do is find out what the angle theta there is. Well, let's just use tangent. Let's just use tangent again. Again, calculator might tell us the right angle, might not. Might give us a reference angle. We got to think through what it's doing here. So let's use the tangent. We know that the inverse tangent, excuse me, I said that wrong. If tangent of theta is equal to negative 1/3, then theta is the inverse tangent of negative 1/3. Type that in your calculator, and we know that we should get an angle somewhere around 340, 350 degrees, somewhere in there. You got to be thinking about what the correct answer is, because your calculator will try and mislead you. What does it report? Negative what? Negative 18.4 degrees. Is that wrong or is that right? That's right. Okay, that's right. It just went in the clockwise direction. It's the same angle. These are called coterminal angles. We're going to work with those tomorrow. But 2 different names for the same angle are called coterminal angles. So it just means you drop back 18.4 degrees. Now, if you don't like that, if you want a positive angle, what's the quick solution to make this positive? Yeah, instead of going around this way, the calculator just took the shortcut and went down, negative 18.4 degrees. So we're going to add 360 to that. And you end up with 341.6 degrees. We got it. Okay, there's our angle. Now, just try it. Clear your calculator. Type 341.6 degrees and hit the tangent button. It had better tell you. I'm going to try and do this. Negative 0.33 something. Sure it did. It knows that the tangent of that angle has got to be about negative 1/3. Now, it's probably not going to be exactly 0.333333 because we rounded that a little. All right. Here's the thing to observe. Down here, for this example, down here in the fourth quadrant, our sine value turned out to be negative. Our cosine value turned out to be positive, and the tangent value turned out to be negative. True or false? For this case, the sine value down here in the fourth quadrant turned out to be negative. Will that be true for any angle in the fourth quadrant? Will the sine value for any angle in the fourth quadrant always be negative, or is it just for this one?
Always.
It will always be negative. Why will the sine value here always be negative? Because it's always going to be opposite over hypotenuse. But your hypotenuse, r value, is negative. That's always positive. Okay, our r value, the length of this terminal side, is always positive. Since the hypotenuse is always positive, and down here, the opposite side will always be negative, you're always going to have a negative divided by a positive. It's always going to be negative. What about the cosine? The cosine here turned out to be positive. Is that always true? It's always true because the cosine, the adjacent side, will always be to the right. It'll always be a positive over a positive hypotenuse. It'll always be positive. The tangent in the fourth quadrant will always be negative because we'll always have a negative opposite side but a positive adjacent. So the tangent will always be negative. Well, each quadrant will always have the same three signs on the trig functions. These you'll need to know, but there's a clever way to remember them. First of all, let's go quadrant by quadrant. There's a lot of information on that chart, but take any angle over here. We don't really need that. In the first quadrant, is your opposite side going to be positive or negative? It's always going to be positive. Your adjacent side is positive. The radius is always positive. So in the first quadrant, sine will always be positive. Cosine will be positive. And tangent will be positive. All three trig functions are positive in the first quadrant all the time. Okay, let's wander into the second quadrant. Let's go over here. Now, for any angle over here, your opposite side is always going to be positive. Your adjacent side, though, will be negative, and your hypotenuse is always positive. So over here, sine will be opposite over hypotenuse. That's going to be positive. Cosine is going to be negative. Negative over a positive. Adjacent over hypotenuse, that's going to be negative. And the tangent here is going to be opposite over adjacent, positive over negative. It's going to be less than 0. Tangent will always be negative. Quadrant 3. The adjacent side is still going to be negative, but now the opposite side will be negative also. So the sine in the third quadrant, will sine be positive or negative? So your terminal side will always leave this reference triangle if your terminal side is down here. So from here, what's your opposite side going to be? It's going to be negative over a hypotenuse, which is always positive. So the sine value is going to be opposite over hypotenuse, which will be less than 0. It'll be negative. What about the cosine? Cosine over here will always have a cosine that is, the adjacent side will always be negative because we're to the left. Hypotenuse is positive. Cosine is always going to be negative. What about the tangent? Tangent will be positive. Tangent will be positive because your opposite side, which is negative, divided by the adjacent side, which is negative, negative over negative will be positive. And in the fourth quadrant, hypotenuse is positive. For any angle with a terminal side over here in the fourth quadrant, your opposite side is going to be negative. It's below the axis, so we're negative. The adjacent side, positive. So the sign is going to be opposite over hypotenuse, negative. Cosine, adjacent over hypotenuse, positive. And the tangent, opposite over adjacent, negative over positive, is going to be negative. Now, there's a whole bunch of patterns in there. If you look at those 12 signs, there's several patterns in here. First of all, notice that for any trig function, just look at sine, for example, there's two quadrants where it's positive and there's two where it's negative. Sine is positive up here but negative down here. What about cosine? Cosine has two where it's positive, two where it's negative. It's positive where the adjacent side is positive. It's negative where the adjacent side is negative. What about tangent? Tangent has got two where it's positive, where the opposite and adjacent have the same sign. And it has two quadrants where it's negative, when the opposite and adjacent have opposite signs. So tangent is negative here and here. Now here's the easy thing to remember. What you want to remember is that all students should take calculus. Because up here, all the trig functions are positive. Up here, only the sine is positive. Here, only the tangent is positive. And here, only the cosine is positive. That will be vitally important. All sine, tangent, cosine, all students should take calculus. Okay. Now, based on that, I'm going to give you a couple of angles. I just want you to predict what the sign on these will be, positive or negative. First of all, the cosine of 210 degrees. Don't use calculator, just think. Will the cosine of 210 degrees be positive or negative? Well, which quadrant are you in? Quadrant 3. Cosine of 210 degrees is going to be down here. Down here is the cosine positive? Nope, it's negative, so it'll be negative. Cosine of 210 degrees will be negative. The next one is tangent of negative 345 degrees. Negative 345, that puts you in this direction. Negative 90, negative 180, negative 270, negative 345. Is tangent positive up here? It is. Tangent will be positive. Next one, sine of 3 pi over 4. Now, 3 pi over 4 puts you in which quadrant? Is that more or less than 1 full pi? It's a little bit less than pi, which leaves you in quadrant 2. Sine of 3 pi over 4 is somewhere up here. Up here, the sine value is positive. And the last one there, cosine of 90 degrees. Now, the cosine of 90 degrees, that's going to be right here. 90 degrees puts the terminal side right there. What's the cosine of 90 degrees going to be? Well, what's the cosine here? Cosine here is positive, but cosine here is negative. That means your cosine is 0. You can verify that on your calculator. Type 90, hit cosine, it'll tell you it's 0. All right. We'll deal more with the cosine of 90 degrees tomorrow. The last thing that is worth knowing how to do here is just to evaluate trig functions of any angle on your calculator. But there's nothing to do there. It's just using your calculator. Let's just do a couple of them together. Sine of 300 degrees. Well, you don't do anything different than you've done before. 300 degrees, make sure you're in degree mode. Want to make it, well, I should have had you predict it, but what, the sine of 300 degrees, that's going to put you in the fourth quadrant. Is sine positive or negative in the fourth quadrant? It's negative, and if you type sine of 300 degrees, it'll tell you that it is negative 0.8660. Secant of 150 degrees. Now, when you consider the sign, SIG, on positive or negative, these three other trig ratios have the same sign as their partners. So what's the partner of secant? Its partner is cosine. So it's always going to have the same sign as cosine. So secant of 150 degrees, we're in quadrant 2. Is cosine positive or negative in quadrant 2? It's negative in quadrant 2, therefore secant will be also. It'll be negative. And if you type 150 degrees secant, or how do you do that on your calculator? It's 1 over cosine of 150 degrees. And if you do that, you should get a negative value. Negative 1.1547. One more. Tangent of pi over 6. Predict the sign. First of all, which quadrant are you in for pi over 6? Which one? Quadrant 1. And is tangent positive or negative in quadrant 1? It's positive, so it should be positive. Make sure you're in radian mode. Put yourself in radian mode. Pi divided by 6. Hit the tangent button. Should be positive. You get should get 0.5774. Gabe? We'll have to leave the last two. We'll be doing more with this tomorrow. We don't try and stuff it all in one day. We're going to work more with this tomorrow. The last thing I'd like you to do is just think about this. I want you to tell me which quadrant this angle could possibly be in. We know that the cosine of some angle is negative, less than 0. So what two quadrants could it possibly be in? Cosine of theta is less than 0. That means it has to be in quadrants 2 or 3. Remember, this is where they're positive. So if cosine is negative, it can't be here. Cosine is positive is here. Can't be there because they're all positive there. So cosine is negative in these two, 2 or 3. Tangent of an angle is positive. We must be in quadrant what or what? 1 or 4. That's right. Oh, I'm sorry, 3. 1 or 3. 1 or 3. 1 or 3. Yeah, 1 or 3, not 1 or 4. And what quadrant must you be in if the sine of beta is greater than 0, but the cosine of beta is less than 0? Where are you if your sine is positive, but the cosine is negative? Sine is positive, which means you're in one of these two, but cosine is negative, so then you have to be in 2. That's right. Got to be in quadrant 2. I know you don't want to leave, but we have to. The class is done.